Group 1, who is group 1? Okay, group 1 finished already, your assignment. Okay, make sure all of you have done your part in the group. Okay, I need it to be a group. Okay, group finish must be in the whole group finish. Okay, so make sure your team member Noel finish everything. Okay. Presentation of your assignment will be, yeah, we will do it in practical time. Okay, so this coming Friday. Okay, so get ready with group 1. So we have 5 group. So we have to finish the presentation by, let me check, by week 14. So for this round, okay, for this week, I only need first group to do the presentation. Okay, so make sure everyone has done their part lah. Okay, make sure group leader do your, yeah, do your part. Okay, make sure all your team member finish everything. Okay, so we're going to start in a moment. So yeah, some of them are not here yet. So by 9:10 a.m. then we'll start. Okay, so you guys can download the PDF file. Okay, in the classroom, I just posted chapter 8. Hello, good morning, everyone. Is everyone here? Can you guys check with your group? Oh, okay, thank you, Noel. Group 2? Only Elvin, Russell. Okay, okay. Check first. Because we are about to start. So only two of them, Elvin. Oh, okay, okay. So never mind. So we just start, okay? All right. So are you guys able to see the screen? Can see, ah? Okay, good, good. Thank you for the response. All right. So for today, this week, we are going into chapter 8, which is transaction processing. Okay. So we're going, yeah, going through this chapter 8. Okay. Hold on, hold on. So we look at the learning outcome for this chapter. Okay. So you must be able, okay, all of you, okay, after you're done with this lecture, you must be able to describe the techniques for data security. You also be able to explain the function, the importance, and properties of the transactions. Describe problems and techniques. Okay. Okay. Sorry. For concurrency control of transaction, and also you'll be able to describe a technique for database recovery. Okay. There are four over here. Okay. Those things that you, yeah, must be able to get. Right. So let's move into the next slide. Okay, so we look at the database software security features. Okay, so the features here include the views, the integrity controls, the authorization, encryption, authentication schemes, and the backup and recovery. Okay, so that's the features. Okay, next page, we look at the views. So what is views? Okay, so views, okay, you can see a subset of a database that is presented to one or more users. Okay, can show to, can view by more than one users. Okay, and then user can be given access privilege, okay, to view without allowing access privilege to the underlying table. Okay, user, normal user, okay, can be given access privilege. So this command, okay, so we can look at this command. Okay, you are creating a view for low stock view as, okay, select wildcard from products, okay, when the quantity in stock lower than 50 with read-only constraint. Okay. So this one they are able to view but not be able to modify anything. Okay. So enable the view. Now integrity control. Okay. What is integrity controls? Okay. It is to ensure that the data entered into the database is accurate, valid, and consistent. Okay, so there are three things there. Okay, and then the three basic types of integrity controls are the entity integrity. Okay, you are not allowing multiple row to have the same identity within a table. Okay, in a row. Okay, and we have a identical. Okay, multiple things the same. Okay, can only be one. It's the primary key. Okay, the other one is domain integrity. There restriction data to be predefined data types. Okay, example the dates, set allowable value. Okay, so example here when you create domain, okay, price change as decimal check. Okay, the value between dot 001 and dot 15. Okay, in between of these numbers. Okay, mean to say domain in a territory. Mean to say the territory is in this range. Okay, so referential integrity. Okay, what is referential integrity? Okay, requiring the existence of a related row in another table. Okay, example, a customer for a given customer ID. Okay, so customer table for a given customer ID. Okay, yeah, customer, and then the one is customer ID as a reference. Yes, a reference table. Okay, so we have summarize on this one the three basic types of integrity control: the entity, the domain, the referential. Okay, and then this accurate, valid, and consistent is to ensure the data into the database. Okay, we have three things that need to be ensured, which is accurate, valid, and consistent. Okay, let's take a look at the referential integrity. Okay, the referential integrity means that if fk contain a value, that value must match a ck in the parent table. Okay, so you can look at here the branch number and the branch number on the staff table. Okay, these are the branch table, these are the staff table. Okay, reference for this two table will be the branch number. Okay, because the branch number they share uh, the same value. Okay, and it must be matched. Okay, just like that. Now we're moving into the next page. Okay, so action taken attempting to update or delete the CK value in the parent table. So here the parent table here is referred to the branch. Okay, with matching row in the child is dependent on referential action. Those specified during on update and on delete sub clauses. Okay. Okay, is cascade, set before, or set now, or no action. Okay. So when you delete B003, okay, let's say delete lah. Okay. Going to delete on this one, what happened? This also will be deleted. And else David and Susan will be deleted because of the branch number. Okay. So when we look back again here, the referential must be matched. Okay. So if let's say the B003 is deleted from the main, okay, say this one is the main, the parent table, okay. Here also the B003 will be deleted as well. Okay. Okay, so we look at this example. Okay, create table staff. Okay, I'm going to create a table staff. Staff number, the variable character, okay, not null. Okay, branch number, okay, variable character, okay, default B005. Primary key is the staff number, and then the foreign key will be the branch number. Okay, references with this branch. Okay, so this one is on updated cascade, on delete set default. Okay, let's move to the next one. Okay, so cascade. Okay, it will delete the row from the parent and delete matching rows in child. Okay, and so on in this cascading manner. Okay, like I said just now. And we delete the B003, the child table also will be deleted. Okay, set null. Okay, delete row from the parent and set the FK column in the child to be null. Okay, it only valid if the FK columns are not null. Okay, if it's not null, okay, then and then when we do this one set default, okay, it will delete row from the parent and set each component of FK in child to be specified default. Only valid if default specified for the FK columns. Okay, if no action, reject delete from the parents. Okay, when you use this no action, set put it over here. Okay, like that. Okay, FK, put it like this one. Okay, the branch number. Okay, it depends okay on what I'm going to type over here. Okay, and to set null everything for this or set default. Okay, you have to make sure the FK columns are not null for set null. Okay, for set default only valid if the default specified for the FK. If it's not, then you won't be able to use that one. All right. So let's move to the next page. Authorization. Okay. Controls incorporated in the TBMS to restrict. Okay. So authorize, of course, you know from the words authorize, then we are allowing or not allowing users to do something on that data. Okay. So that's why I say control incorporate in the database management system to restrict access to the data or action that people can take on the data. Okay. Access and to say execute the data, action or modify, something like that. Okay. So you can see here authorization table for subject, okay, let's say for the salespeople. Okay. For customer record, yes, you'll be able to read, insert, you're able to insert, modify, you're able to modify, but you aren't able to delete. For the order record, yes, you're able to read, you're able to insert, unable to modify, and you're unable to delete. Okay, insert meaning to say here you put a new value like that. Okay, modify meaning to say you change the value. Okay, change something that already in those table. Okay, like that. Delete, of course, delete the whole things lah. Not to say the whole things, but maybe one row or maybe two row, something like that. Okay. Sorry. When we look at this one, authorization for table for object. Okay. Salesperson, the order entry, accounting. Okay. Read, of course, not able to read, not able to do anything. Only able to read. For order entry, Okay, they are able to read, insert, and modify, but they are not able to delete. Accounting, they are able to read, they are unable to insert, okay, insert new things, but they are able to modify things that are already in, and they are able to delete. Okay. Oracle privilege. Okay, so this privilege can be granted to users at the database level or table level. Okay, insert and update can be granted at the column level. Okay, column B is something like this. Okay, column. So we look at this privilege and the capability. So we type select. Okay, used to query an object. Okay, so that's why we type select, and then because we want to query the object. Okay, insert a record into a table or view. Can be given for specific columns. Okay, updates. Okay, so update record in a table of view. Okay, can be given on a specific column. Okay, delete. Require a delete record from the table. Alter, we go into alter. Okay, index, create index on the table. References, create foreign key that reference the table. Okay, and then execute the procedure package or function. All right. So just now, we are still in the authorization. Okay, still in authorization. Okay, so we look at this authorization matrix 4. Okay, this authorization matrix 4 is for the subject, object, action, and the constraint. Okay, so we look at the subject. The subject will be the sales department um, or the transition, terminal, accounting department, and worker program AR4. And the object sales department will be the customer record, the order transition or transport. Okay. Not sure what does it means here. Okay, the object will be the record, customer record, and then the terminal also will be customer record, and the rest will be the order record. Okay, so action here. Okay, for sales for this thing will be insert. Okay, they're able to insert new data. Okay, so this one they're only able to read, able to modify, unable able to delete, able to insert, and able to modify. And then the constraint. Okay, credit limit up until 5,000. This is none. Okay, no constraint at all. And then this one is only balance. This one none. Okay, no constraint. And then this one order limited to 2,000. And for the program, will be none. Okay, this is only an example. Okay. Okay, so we look here. The owner of a relation R is given all privilege on R. Look at this one. Okay. So the owner account holder can pass privilege to the other user by granting privilege to their account. Okay. If you allow it, okay. In order to do that one, okay. Grant select update okay, the salary on the staff to a personal or director. Okay. Then this one grant privilege list. Okay. All privilege on which one object name will be this one now. Okay, to authorization list. So the authorization list will be public. Okay, with the grant option. So we can see over here, okay, with grant action, the user receiving the privilege may in turn grant it to other user. Okay. So to create a view, the account must have select privilege on all relation involved in the new definition. So all of this one is just to pass the privilege. Okay, now we look at this command, revoke. Okay, grant option 4 and the list of privilege, all the privilege, okay, on the object name from the authorization ID list, public restriction cascade. Okay, how you can do like this one. Okay, revoke all privilege on staff from director. Okay, so all privilege refer to all privilege granted to a user by user revoking the privilege. Okay, so the syntax, and this is how you do it. Okay, and the object name here, okay, from the staff. Okay, from staff from the director. The director will revoke all the privilege on staff. Okay, that's how it means. Okay, and the example, okay, here, it's an employee, okay, employee table. Okay, we have name, the SSN, birthday, death, no mistaken, address, sex, salary, and okay, not sure what is DNO lah. Okay. Okay, so suppose that A want to allow B to retrieve only the name, the birthday, and the address attributes, and only for the tuples with DNO 5. Okay, for B to propagate the privilege. So how can this be achieved? Okay. So to be achieved on this one, okay, for B, we do this one. Okay, we create a view for B employee. Okay, just here they want it to be name, birthday, and address. Okay, and the DNO, the DNO, say okay, only at 5. Okay, maybe at row 5, I believe. Okay, so we create a view B employee as select name, the birthday, the address. Okay, from the employee table where the DNO is equal to 5. Okay, this is one syntax. And next, grant select all B employee to B with grant option. Okay. All right. So that is authorization. And for this encryption, we are going to continue after we take a break. Okay. So it's about 9:34 already. So let's take a break for a while. Okay. About 10 to 15 minutes. Okay. Then we'll continue back. All right. Okay. So we'll see you guys at 9:45, 9:45 to 9:50. Okay, so let's take a break for a while. All right. All right, so we shall continue. Okay. We are we already? All right, so we continue with the next topic, encryption. Okay. So let's take a look at the encryption here. All right. Yeah, hopefully you guys able to hear my voice now. Okay, so when we look at the encryption here, okay, just look at this picture first. Okay. When you type something like, okay, let's say it's a plain text. Plain text means to say a text that you're able to read. Okay. When you're going for the encryption algorithm, okay, it will become something that you are not able to read. Okay. Encryption here, the coding or the scrambling of data so that humans cannot read them. Okay. So let's say here you put the text is 1234, and then when it goes into the encryption algorithm, okay, what happened with the 1234? It become not a number. Okay, might be a combination of number, text, symbols, like that. Okay, and it will scramble everything so that human are not able to read. Okay, you only write might be 4 text, but when it get into the encryption, it can be more than 10, more than 20. Okay, text like that. Okay, and these are, okay, when they're going into this encryption algorithm, it's actually a key, a public key. Okay, public key meaning to say is of course it's a public key, but this one is in terms of security. Okay, when you're going to this decryption, okay, meaning to say, yeah, you're going to decipher the encryption. Okay, you need a private key. So this private key is only happen to be at the, okay, it's either the receiver or the sender itself. Okay, have the private key to decipher the encryption. Okay, so you will look at here. Okay, secure socket layer, the SSL is a popular encryption scheme for TCP/IP connection. Okay, but we are not going to look at on how to do the encryption, on how to create the algorithm for decryption. No, we are not going to do that one. Okay, just for your information. Okay, so the authentication schemes. Okay, so we have the authorization, and then the other one is the encryption. Okay, so authentication schemes here. Okay, is the goal, okay, to obtain a positive identification of the user. Okay, you need to make sure that the user are valid. Okay, so here password, okay, will be the first line of defense. Okay, so the password, okay, the complexity is requirement. Okay, require a complexity of the password. Okay, and it should be changed frequently. Okay, but yeah, sometimes people will not change the password, okay, frequently lah. Okay, normally they will use one password for all. Okay, and yeah, okay, some of them might be, how to say, they keep their password in the notepad, in the, maybe in the PC, the phone, okay, something like that. And it could be risky when you do that one. Okay, and we look at this two-factor, okay, smart card plus PIN. Okay, require two-factor, okay, to be authenticate. Okay, using a smart card. Okay, after using a smart card, okay, and then you use a PIN. Okay, to make sure that you are valid. Okay, and also there are three factor. Okay, to get authenticated by using smart card, biometric, your fingerprint, and then your PIN number. Okay, there are three things. If they match, then you are authenticated. If it's not, then okay lah, you are not the right person. Okay, so biometric device, what is biometric device? Okay, it is of fingerprints. Okay, it can be a iris scanner, the retinal scan. Okay, those two are biometric. Okay, what else? Okay, biometric is your iris, your eyes, your retinal, and your fingerprint. Okay. And then the third-party mediated authentication using secret keys or digital certificate. So this one using key secret and digital certificate. Normally this one happen in a web page. Okay. Web page means to say the website lah. Okay, some of the website require digital certificate. Okay. Why do they need this digital certificate? To ensure that the how to say you are the correct person to get to this website. And because normally those websites are not public to all, it's a private network, private website. Okay, normally it's like that. Okay, so we get into the number 2 point, transaction support. Okay, so what is transaction support? Okay, so we look at this one, action or series of action, okay, carried out by the user or application which reads or updates contents of the database. Okay, it's an action. Okay. Number 2, a logical unit of work on the database. Okay, logical, it's not a physical. Okay, so that is transaction. Okay, an instruction for specifying boundaries of a transaction, which is the begin of the transaction. Okay, they are commit. Okay, transaction is completely successful. Okay, example, the database is transformed from one consistent state to another consistent state. Okay, meaning to say transactions is completely completed. So meaning to say there will be and updates. Okay, for that one. Rollback meaning to say transaction is aborted. Okay, so you need to get back to the previous state. Okay, database is restored to the consistent state it was before the transaction started. Okay, so commit meaning to say successfully complete. Rollback meaning to say it's already successful, but we need to abort those transactions. We need to delete those new transactions. Okay, back to the original form like that. Okay, so we look at these ATM transaction examples. Okay, the ATM. Okay, so look at this one, begin transaction. Okay, so display the greetings. Okay, get account number, PIN, type, and amount. Okay, so select. We're going to select the account number, type, and balance. If balance is sufficient, then update account by posting debit. Okay, insert history record. Okay, and then display message and dispense cash. Print receipt if requested, and if on error. Okay, and if on error, they roll back the commit. Okay, so this one begin transaction is the beginning of the transaction. Okay, and they will display a greeting. Okay, that's why whenever you go for ATM, okay, when you put in your card, okay, they will display the greeting first. Okay, then they will get your account number from the card you put in, and then we require you to enter your PIN, okay, and amount that you are going to take. Okay, something like that lah. Or might be here amount. Okay, they will calculate amount inside your account, and then select. Okay, select the account type, account number, the type, and the balance. Okay, I think other than these three things, when you have the balance, okay, the balance is enough, okay, for you to withdraw, okay, then they will update the account while posting a debit message successful, okay, and then they will insert a history record that you have been taken out, withdraw amount of money, and it will display a message and dispense the cash, okay, and then the print receipt if requested, okay, and if okay, if there's an on error, okay, on error means to say your transaction is not enough balance, they will do a rollback. If not, then it will be commit. Okay, so that is one of the example of this one, okay, transaction examples. Okay, and then in the transaction properties, it will be the ACID. Okay, so the A stands for the atomicity. Okay, all or nothing. Okay, consistency, database must be consistent before and after a transaction. Isolation, okay, partial effects of incomplete transaction should not be visible to the other transaction. Okay, and then the durability. Okay, effect of a committed transaction are permanent and must not be lost because of later failure. Okay, so these are the properties that need to be in the transaction. Okay, have or not have, yeah, like that, automaticity. So consistent, of course, you can read this one. Okay, must be consistent before and after transaction, must be consistent, cannot be sometimes, okay, the database can be error, wrong, like that. Okay, isolation again, if there is any effect of the incomplete transaction, mean to say sometimes like there is no electricity, okay, something like that, okay, there is no enough power, okay, normally electricity, okay, then you are not able to do the transaction, then it will be inside this isolation, okay, and it will not affect the others, okay, and of course everyone will be rolled back again to the previous state. Durability, of course, all the history will be remain there, okay, for future references. Okay, so that is ACID. So now we look at the concurrency control. Okay, so process of managing simultaneous operation on the database without having them interfere with one another. Okay, so meaning to say here, okay, in the database there are two things happen, okay, at the same time. Okay, so prevent interference when two or more users are accessing the database simultaneously and at least one is updating a data. Okay, so although two transactions may be correct in themselves, okay, interleaving of operation may produce an incorrect result. Okay, so means if there are two users doing the same thing, not to say doing the same thing, it might be, yeah, they do the same thing but different purposes. Okay, will be like that. Okay, so let's take a look. Okay, so three examples of potential problem caused by the concurrency. Okay, loss update problem. How can it be loss update problem? Because one of the person, okay, might be doing something, and at the same time this person also doing something. When they first look at the original state, okay, so let's say the original state is, okay, just play with the number. Okay, original state is 10. Okay, so both of them are seeing the number 10, but when this person do something about the number, it might be this person deduct the number by 3, so it will be supposed to be 7, but this person on here still believe it's a number of 10. Okay, so when you do something on it, okay, then this is the cost, okay, loss update problem, because this person, they are not getting any update when this person over here already took 3 from the number 10 just now. It's supposed to be 7, but just because they are going in at the same time, okay, the update might be problem, okay, not being updated during this person looking at the current state, okay, something like that. Okay, uncommitted dependency. Okay, problem, it is the dirty rate. So it's the same thing. Okay, when this person already commit, like I said just now, already took 3, okay, commit, but this one still are not able to see those things that have already been commit. Okay, might be this person are looking those state are very fast. Okay, before this person commit to the state, okay, it will be something like that. Okay, that's why I say uncommitted dependency. Okay, so you must have read it incorrectly, and then inconsistent analysis problem, the same thing like I said just now. Okay, this person see the state in current 10, but when this person do something on it, this person still believe it's only 10. Okay, the number 10 is still there, but actually this person has already deduct the number. Okay, something like that. So these are the 3 things lah. Okay, the potential problem with the concurrency. Okay. So a loss update problem. So we take a look at this one, loss update problem. Okay. Successfully completed update is overridden by another user. Okay. Same concept like I said just now. Okay, this one is a time, okay, time 1, time 2, time 3, time 6. Okay. So time 1, time 2. Okay. So we look at this one. These are the time 1 transaction. This is time 2 transaction. Okay. So when you look at this one, loss of T2's updates can be avoided by preventing T1 from reading balance X until after update. Okay, so T2 loss update. Okay, actually. Okay, when we look at this one, okay, X is equal with X minus 10. Okay, this one X plus with 100. Okay, so they begin transaction at the T1. Okay, so meaning to say this T2 has done the transaction at the first place. Okay, and to read the balance on the T2. T3 will read the balance after this thing happened. Okay, so meaning to say on this transaction, okay, they read the balance and then the balance plus with 100. Okay, plus with 100. So currently the balance is 100. Okay, then this person they add 100 on its account. So it's supposed to be 200, but for this person, this T1, okay, to avoid the T1 from reading the balance, okay, it will need to wait for this update. Okay. See here, this one's supposed to be 200. Okay, but when you look at here, it become 90. How come it become 90? Because this one is there. Original they have 100, and this person, this user plus 100 supposed to be 200, and for this person they only took out 10. It's supposed to be 190. But just because of this thing, okay, it become 90. And because on this user, it still believes that the balance is 100. Okay, still believe the balance is 100 because it has not been committed yet. during this time. Okay, they read the balance during here. Okay, right, but has not been updated. Has not been updated because it has not been committed yet. So we look at this timeline. Okay, so that's why it's a loss update problem. Okay, the other one is uncommitted dependency. Okay, the period problem. Okay, occurs when one transaction can see intermediate result of another transaction before it has been committed. Okay, so now here, read the balance before this one have commit. Okay, commit the transaction. Okay, so we look at this one. Okay, person one, a person. Okay, so we just assume this is user one, this is user two. Okay, so we look at here. Okay, so this user, okay, try to deduct them, and but this user is adding up 100, okay, into the balance. Okay, so at this timeline, okay, that the T2 here, user 2 read the balance 100. Okay, then they add another balance is 100. Okay, then it write the balance 200, but it not yet has been committed. Okay, not yet committed, but on this user one, when you begin the translation later at this timeline of 4, okay, then when they read the balance, what happened? It sees that the balance is 200. Okay, it sees the balance 200. But actually, this balance is not being committed yet. Okay, it's not being committed yet. So what happened at this side? Okay, they will minus 10. Okay, and we will write the balance. Okay, write an update. Okay, negative 90. Oh, sorry, negative 90. Yeah, supposed to be negative 90. Okay, but before this one, write those things. Okay, because this balance it reads as 200. Okay, but this one it roll back at this timeline at T6. Okay, it back to 100, but just because of this user, okay, all the memory here, the balance is 200. So when it write and then write the balance, okay, after the deduction by 10 is 190. Just the balance, okay, the balance here, it refer the balance on this timeline, okay, which is still 200. Okay, so that's why when they commit, it become 190. Okay, so here the balance will be not correct anymore. Okay, that's because of these things. Okay, uncommitted dependency. And this problem can be avoided by preventing this user, the T3, from reading balance until after T4 commits or above. Okay, and this example, read the balance before this user commit or roll back the transaction. Okay, so you can see the difference in this one, how they track with the balance. Okay, if this happen to a bank account, okay, it's easy to hack actually. All you need is 2%, and playing by the time, and then you can add your balance like that. But luckily, it's not happen in the real bank account now. Okay, so we look at the inconsistent analysis problem. Okay. So it occurs when a transaction reads several values, but second transaction updates some of them during execution of first. Okay, so what does it mean? Okay, so we look at here. So we have another two user also. Okay, two user as the example. Okay, so we look at here. Okay, okay, so this is user 1, this is user 2. Okay, we just assume like that. Okay, so user 1 will do this one. Okay, they will deduct 10 on this account X, and this account Z, they will add 10. But for this, okay, sorry, this user, the second user, okay, they will sum all this transaction. Okay, so now take a look at this one. Okay, the beginning of transaction start from the user 2. Okay, so currently the sum, okay, you just look at this one. Okay, sum is 0. Okay, they will read the balance. Okay, so both of these two users are reading the balance. Okay, reading the balance of X. Okay, so both are 100. Okay, and this person, okay, they're going to divided, sorry, not divided, okay, they're going to deduct by 10, okay, minus 10 for the balance X. Okay, and this user 2, okay, we will sum plus the balance X over here. Okay, we look at the sum here. Sum current is 0, but when they plus with balance of 100, it will become like this. Okay, 100 and this one minus 10. Okay, supposed to be, okay, the balance X will be 90. But at this user 2, what it get, the sum is 100. Okay, it add the 100 before this one minus it. Okay, so when they're going to write the balance, they will, yeah, modify the balance, it become 90. And this one already starting to read at balance Y, which is 50. Okay, then after that is we read at balance Z, which is 25. Okay, and for this one we will adding up to the sum. Okay, the balance Y, so 50, then we adding 50 over here. Okay, so next this balance Z, okay, they will add 10 on this user 1. Okay, they will add 10. Okay, then next period, okay, next timeline, it will write those adding 10, so it becomes 55. Okay, become 55. So now when this user 2 read the balance of Z later at this time, okay, and during this time this user 1 is committed the transaction. Okay, 55. So and they're going into sum everything for X, Y, and Z for user 2, getting 1 at 5. Okay, okay, and when this one committed, looks here. Okay, 90 plus 50 plus 35, the sum is 1 at 5. Okay, is it tally? No, okay, it's not tally here. Okay, it's completely not tally because this one is only need to sum all these balance X, Y, and Z. Supposed to be 100 plus 50 plus 25 will be 175. Okay, but instead it gets 1 at 5. Okay, it gets the number 100 before it become 90. Okay, supposed to get 25, but it adding up when the balance Z is raised by 10, which is 35, and you'll be getting 1 at 5 at the sum. Okay, so you can see here again, this is an inconsistent analysis problem. Inconsistent problem. Okay, and actually this is what happens when they are allowing two users to connect at once. Okay, so this problem can be avoided by preventing the T6, this person, from reading balance and balance until after T5 completed the updates. Okay. So that's how it's going to be avoided. But the best solution is only let one person to get in to do transaction. Okay. Other user is restricted until one person have done their path. Okay, like that is much more efficient. Okay, other than this thing happen lah, but you can allow this one if you're able to avoid this thing. All right, so let's move to the another page. Okay, serializability. Okay, so a schedule. Okay, serial schedule and then non-serial schedule. Okay, so we look at the schedule first. Okay, this schedule is a sequence of reads and writes by set of concurrent transactions. Okay, a sequence of read. Okay, just like this one. Okay, for the T1, okay, it begins transaction for this user. Okay, the beginning of transaction for this user 2 will be at the T4. Okay, something like that. Okay, serial schedule, okay, operation of each transaction are executed consecutively without any interleave operation from other transaction. Okay, so when you say serial, it will become like this lah. Okay, this T7 will do something at this period of time, and this TF will do this period of time like that. Okay, so a non-serial schedule operation from set of concurrent transactions are interleaved. Right? So we take a look at this one. So this is a non-serial schedule. Okay, for a serial schedule, they will let one person to finish everything until it commit, and the second user will begin its transaction. Okay, if you look at this one, it's a non-serial. Okay, beginning read and write, then yeah, then the next person are able to read and write. Okay, read and write, commit, and read and write, commit. Okay, something like that. And serial, they will let everyone finish until it commit, then it will go to the next user. Okay. So that is the example of serial schedule. And we have how many schedule? Schedule, serial schedule, and non-serial. Okay. So let's take a look at this one again. Okay. Objective of serializability is to find a non-serial schedule, okay, that allow transaction to execute concurrently without interfering with one another. Okay. The objective of serializability is to find the non-serial schedule. Okay. So in other words, we want to find a non-serial schedule that are equivalent to some serial schedule. Such a schedule is called serializable. Okay, serializable. Okay. So it's similar like this one. Okay, the non-serial schedule will become like this. Okay. See here, these are the serial schedule. This one is a non-serial. Yeah, sorry, this is a schedule, this is a non-serial. Okay, can recall this one. Okay, a sequence of read and writes. Okay, read and write, sequence, sequence, sequence. Okay, for the non-serial schedule, it will be like this one. Non-sequence of read and write. Okay, read, write, then this one read, read, write, write. Okay, it's not a sequence. Sequence will be like this: read and write. Okay, it's like a sequence of read and write by set of concurrent. these are the serial schedule. Okay. So in serializability, okay, ordering of read and write is important. Okay, so why it is important? Okay, there are three factors over here. So we will look at number one. Okay, if two transactions only read a data item, they do not conflict and our order is not important. If it's read only, then okay, no problem. Okay, if two transactions either read or write separate data items, okay, they do not conflict and order is not important. Okay, if one transaction writes a data item and another reads or writes the same data item, order of execution is important because it's the same data. If it's not the same data, separate data items, then it should be no problem. Okay, we need to say here there are two transactions. Okay, the two transactions is either separate data item or same data item. If separate data item, then the order is not important. But if it's the same item, order of execution is important. Okay, so you can see those things. Okay, right, so let's move on. Okay, so I believe before we start with this, the 2.3 concurrency control technique. Okay, so I believe let's take a break for a while. Okay, because it's about 30 minutes. Okay, I believe, yeah, all of you guys need a bit of rest. Okay, so that we can continue with this lecture. Okay, so let's take about 10 to 15 minutes break. Okay, all right. Okay, so far, do you guys have any problem with your assignment? Is there any problem with the assignment, you guys? Or you guys, so far okay? Is there any of you have problem with the assignment? Yeah, I believe this one, everything is simple. Okay, yeah, start with group one. Oh, okay, so whose group finished already? Which group? Because we need to start, okay, by this coming Friday. All right, is everyone here? Yeah, Noel. Okay. All right. So, well, yeah. So, before I continue with this lecture, I believe I will postpone this. I mean to say this lecture will be continue next week, lah. And I just want to go through with you guys your assignment. Okay. So, okay, I stop sharing first. All right. So far, all of you have 5 group, is it? Here, I can check your group member first. Let me check. Okay, group 1 will be Noel, Kelvin, and Farah. Okay, so in group 1 who have not finished the task yet, Noel, you done your part, is it? Okay, what about Kelvin and Farah? Have you guys done your part? Okay, is there still a lot, Kevin? Your part is in, if not mistaken, in chapter 4, if I'm not mistaken. Is it chapter 4? Same with you, Farah. Okay, group 2? Have you guys done? All of you. Okay, 3 of you haven't done anything yet. Okay, group 2, only you have not finished yet. Okay, Nathan. Is it only you or all the... Okay, left a few, so yeah, need you guys to finish it off by this week lah. Okay, because the submission deadline will be 1st April. 1st April will be tomorrow. Okay, you need to submit by tomorrow. Okay, before 10 p.m. midnight. Okay, so I believe you guys understand with this. Okay, and you know what happened if you're late on the submission. Okay, 1 to 3 days late will be deduct 10 marks. Okay, 4 to 7 days, okay, will be deduct 20 marks. Okay, if more than the 7 days, then yeah, the submission will be 0. Okay, so make sure you finish everything by tomorrow. Okay, don't be late. Okay. When you all of you, 1st April isn't Friday. Is it Friday? 1st April? If it's Friday, then yeah, that will be Friday lah. Yeah, Friday. Sorry, I thought March only have 30 up until 30. Okay, there is 30, 31st pula. Okay, never mind. Okay lah, so Friday 10 p.m. lah. Okay. So you got your topic already. So all of you have your topic. Okay, supposed to be you have done with the queries, everything lah. By this week. Okay, so all of you guys Can you guys manage to send your report by this Friday? Yeah, don't say not sure lah. Make sure you can do that. Okay, Jonathan, good one. Okay, so if like this, I think the presentation will be start next week lah. Okay, so all by this week, I need you guys to turn to submit all your assignment. Okay, instead of video you need to submit no video, is it? Okay, only the assignment. Okay, so submit the assignment by this Friday, okay, before 10 p.m. and we set the date for the presentation. Presentation will be next week during the practical. Yeah, of course you need to. It's not stated in the specification. Okay, let me check first. Check. Okay. Oh, yeah. Okay, so your query code, that one, Jonathan, I believe you need to put it in the your assignment. Okay, let me check. Okay, hold on. You mean in the report 4.1, is it? Yeah. Yeah, of course lah, in chapter 4 and chapter 5. Correct lah. Yeah, the report, yeah, that one will be enough. But you need, of course, you need to present your report lah. Not only the report, you have to run your SQL also. See whether they're able to run or not. Okay. Yeah, correct, Jonathan. Okay, so is there anything else? Okay, if there is, sorry, okay. So if there anything, I will update with you guys, okay? Anything regarding the assignment, okay? To make sure that you guys truly understand the assignment, okay? I believe Miss Christie already got you guys, okay? All you need to do is just follow all the instruction. Okay, is there anything else from you guys? Okay, so I believe everything is clear. Okay, so we're going to start the presentation by next week. Okay, next week during the practical hour. Okay, So hopefully we can finish the practical early lah. Okay. Then we see how. If we are able to finish the practical early, then no, Friday is practical. This coming Friday is practical. All right. So if by next week Friday we have, okay, so we might took around 30 minutes, 30 to 1 hour lah. See if we able to do two presentation. If not, then one is enough lah. Okay. And if you are able to finish all the lecture up until chapter, I believe in chapter 10, okay? Up until chapter 10. Oh no, chapter 9. 9 or 10, let me check. Yeah, up until chapter 9. Currently we are in chapter 8, okay? When we're done with chapter 9, then those free time we are going to do the presentation, okay? So I believe everyone is clear, okay? So do submit your assignment before 10 p.m. this Friday and get ready with the presentation next week, okay? Make sure everything runs smoothly. Okay, I believe you guys already seen the rubric, okay, on how the marks will be given. Make sure, yeah, you guys can score. Okay, I think that's all for today. Thank you, everyone. So I'll be seeing you this Friday for practical. Okay, stay safe, everyone.